All right, good evening. My name is Sepper, and this is my teammate Zafar. Our project is Autoannomi, which is a framework to automate the annotation of MI conversations using LLMs. Yeah. So for introduction, what is motivational interviewing or MI? It is a form of counseling with a goal to evoke and strengthen a person's motivation towards change. And it is consisted of 4 major principles, which includes reflective listening. So MI practitioners should adhere MI principles, and MI experts are hired to evaluate the performance of MI practitioners, which are therapists, basically. So these experts annotate their conversation between a therapist and a client using a coding system, which is the Motivational Interviewing Skill Code, or MISC. So they can provide feedback to the therapist. So the challenge with this method of annotation is that it's very resource intensive. It requires MI expertise, and the time gap between a conversation and the feedback could be massive. So by automating this process, we aim to reduce the workload on MI experts and provide near instant feedback. So our solution is to build an LLM-based system that helps experts in MI annotation. So to realize our solution, we have to answer some questions that if LLMs can detect if a therapist is making a reflection, or can it distinguish between reflections if it is simple or complex? To give an example, the left box shows a simple reflection because the therapist is essentially just rephrasing what the client had already said, but the right one is a form of complex reflection, since the therapist is adding insight to what the client previously said. We also wanted to experiment with advice labeling, so to see if LLMs can detect between an advice given with permission by the therapist or without permission. So the data we're using is the Autoannomi dataset for testing our LLM. It is consisted of 133 expert annotated MI transcripts. You can see 2 instances of the data there. There are multiple problems with this dataset. There are some duplicate or inadmissible transcripts. There are some mislabelings regarding the speaker in some of the instances. And yeah, so the steps we took were removing unusable transcripts. We also fixed the mislabelings using GPT-4, and also added our own self-assigned advice label, which is based on the MISC guidelines, to the conversations, which here you can see an example, and that is our data split. So
the first task that we wanted LLMs to perform was to detect whether a therapist utterance has a reflection and whether that reflection is simple or complex. We formulated this problem as a 3-class classification and used the GPT-4 preview for this classification. We experimented with lots of prompting strategies, including varying the task description, providing more conversation context, and providing more examples and chain of thought prompting. These are our results. A prompt can be broken into different components, and we wanted to see the impact of one component over the accuracy. As you can see, providing more elaborate descriptions and providing more conversation context improve the accuracy a lot. Few shot and chain of thought prompting improve the accuracy further. We try to analyze the errors made by the LLMs, and we couldn't find any glaring errors. Most of the incorrect classes, in our non-expert opinion, are very ambiguous or can be classified either as simple or complex reflection. On the left is an example where the LLM classifies this as no reflection, but the dataset label was simple. On the right is a very interesting example. Only chain of thought prompting strategy could give us the right label.
So we did similar experiments with the advice label. We did the same 3-class classification. We've got the advice with permission, advice without permission, and no advice. We used a total of 45 examples from the Autoannomi dataset and used the same previous prompting strategies, which the best accuracy we got out of them was 84%. and we could see that GPT-4 was well equipped to predict the labels, providing few shots, doing few shots or chain of thought prompting using more context did not help much. And also from the chain of thought reasoning, we saw that even for false predictions, GPT-4 gave pretty good justifications for its answers. So maybe the problem was because the data was self-assigned, it was just we assigned the label wrong because we are not expert annotators.
All right, so some retrospective thoughts. We overestimated both our budget and the difficulty in labeling. Our advice labeling was a totally new class, and we did not have many examples for negative or positive classes for permission. We could have formulated the problem differently as well. So yeah, thank you.